Find all horizontal and vertical tangents to the curve xy. So the x-coordinate given by the formula 80t minus t to the 5, and the y-coordinate given by e to the minus t squared. Okay. So horizontal tangents, when does that happen? Well, the easiest way for that to happen is for the derivative of the x-coordinate to not be 0. So there is some change in the x-coordinate. There is some horizontal movement, but no change, no vertical change, no change in the y-coordinate. And vertical tangents are sort of the flip. There is, oops, not an x down there, it's a t. There is some change vertically, some change in the y-coordinate, but there is no change in the x-coordinate. Okay. So to answer this sort of a question, we need to get the dy by dt's. We need to get the dx by dt's. So we've got 80t minus t to the 5 and e to the negative t squared. 80t minus t to the 5 and e to the negative t squared. So I'll slam the little xy's over there. Okay, so we just got to differentiate dx by dt. This isn't bad at all. I mean, this one here is a polynomial, so certainly doesn't take too long. 80, and then the 5 comes down, 5t to the 4. Great. And then dy by dt, the derivative of e to the minus t squared. Now, for this one, you could, I mean, depends on your skill level. You might be able to just sort of look at it like that. I've done hundreds of these, so yeah, I'm at that stage. But if you need to, break it down to something like the chain rule. Okay? Chain rule and say, hey, this is e to the t, but with minus t squared plugged inside. And so the derivative would be the derivative of the outside function, so e to the t, with the inside function plugged in again, times the derivative of the inside function. So that would be minus 2t. Okay. Nothing wrong with going slower like that and making sure you've crossed all your t's and dot all your i's. So this is a chain rule. Okay. I might choose to write this as minus 2t e to the minus t squared. Because I always was taught, put your polynomials before your trig, before your exponentials. Other people have different orders, and honestly, it doesn't really matter all that much. Okay, now, since this is a question asking for both horizontal and vertical, we should find out where both of these are equal to 0. If the question was just asking me for vertical, I would say, okay, when is this, the dx by dt equal to 0? And then I'd plug them into the dy by dt just to make sure that was not also 0. But since we need horizontal and vertical, we're going to have to set both of them equal to 0. And then hopefully there aren't any overlaps in the list, because then we might be dealing with cusps or something that has to be resolved in other ways. But yeah, so if we take the first one, rearrange it, divide by 5, we see, oh, okay, t is 2 or negative 2. Right? T to the 4 equals 16. Those are the two options. So when t is 2, there will be no change in the x-coordinate. The curve sort of stops moving horizontally for a moment. Same thing when t is negative 2, wherever that point is. Okay? And since the question does ask for us for the tangent lines, it is not going to be enough for us to say 2 and negative 2. We're actually going to have to say, oh yeah, the vertical tangent lines are x equals 1 and x equals negative 5. We actually do need the curve, the lines here that are tangent to our curve. Okay? But we'll get to that. So that was when dx by dt is 0. How about when dy by dt is equal to 0? Well, minus 2t e to the minus t squared. When is that guy equal to 0? Well, we have a product of things. We have negative 2. Well, that's never 0. We have t, and we have e to the minus t squared. And a product of things is equal to 0 only if one of those things is equal to 0. Okay? And exponentials are never 0. Obviously, negative 2 is never 0. So this can really only happen when t is 0. So when t is 0, we should have no change in the y-coordinate, so that should give us a horizontal tangent. And when t is 2 or negative 2, we should be looking at a vertical tangent line. Okay? So these are the parameter values. So you're plotting points on your curve, and your curve is doing this or that. At negative 2 is where you'll get a point that's vertical, but that's t is negative 2. Again, the x value might be like x equals 1. So we are going to have to plug these in to figure out the actual horizontal and vertical tangent lines. If we go back and read the question carefully, you should always read a question carefully, find horizontal and vertical tangent lines. So we know vertical tangent lines all look like x equals some value. We know horizontal tangent lines always look like y equals some value. So we need to take the 2 and the minus 2 and plug them in and figure out, well, what is this x coordinate for the vertical tangent line? And then same thing with y. We'll have to plug in t equals 0 to figure out the y coordinate for the horizontal tangent line. How high up is it? Where's our tangent y? All right, so that's what we got to do there. So, okay, let's get a fresh sheet of paper and go ahead and do that. So we have 80t minus t to the 5, and we're going to plug in t equals 2 to get the x coordinate. Right? This is just the x coordinate, which is all we need to reference a vertical tangent line, or just a vertical line in general. So we'll have 160, just plugging the t in there, minus 32, 128. So x equals 128 is a vertical tangent line to this curve. It happens when t is 2. That's when the curve, maybe I guess bumps up against it like this. T is 2 here, but the actual x coordinate is 128. All right, what happens if t equals negative 2? Well, you'll have 80 times negative 2, so negative 160, and then minus negative 32, negative 2 to the 5. So that'll be negative 128. So x equals negative 128 is also a vertical tangent line. And what's the y coordinate for our horizontal tangent line? E to the negative 0 squared. Well, that's just 1. So y equals 1 is a vertical tangent. So no, not a vertical tangent, a horizontal tangent. So let's summarize this. The vertical tangents to this particular parametric curve, the vertical tangents are x equals 128 and x equals minus 128. Really big. I probably wouldn't want to sketch the graph of this because the things would be really far out. Although I guess I could zoom out. And what's the other one? The horizontal tangent line, which there is only one of. Y equals 1. Okay, so if we were to imagine the graph, y equals 1 is like here, and we're really far zoomed out. X equals 128 is here, and x equals minus 128 is here. So I don't know exactly how this curve, maybe it goes something like this, and then it just touches here, and then maybe it sort of bounces up here and just touches at some point here. But it has a horizontal tangent line, and then maybe it ping-pongs back down here, and maybe goes on its merry. I have no idea. I'm not going to stop and sketch it, but just to imagine what this looks like, yeah. Sort of round, nice, smooth, but we have 2 verticals and 1 horizontal tangent line to this curve.